So what we're going to do now is have a look and see how we can test the hypothesis whether the mean weekly shopping value for the Wagga shopper data is $156. So the first thing we need to do is import the data. So we change it to an Excel file because we've got our data saved in an Excel file. Just navigate now to find the data. And here's our data. So as we saw earlier, it's just a list of, in a single column, of all the amounts that were in our sample for the different weekly spending amounts. And so what we want to do is find out whether these values, the mean of these values, is equal to 156 or not. So we're going to do an independent t-test. So we're going to go to compare means, one sample t-test. Sorry, they weren't independent samples, it's a one sample t-test because we've only got one sample. So I've just put the weekly spending amounts into the test variable box, and I'm going to add 156. Now this is the hypothesized value. We want to see whether the values here that we've collected in our sample have a mean of 156 or not, and that's after we take into account the variation to do with the sample. If we were to want a 99% confidence interval or a 90% confidence interval, say we would come in here and change this to 90 or 95. The most commonly used value is 95, and so that's what we're going to stick with here. And if I don't stipulate a confidence level or a significance level, then use 95%. And we just say OK, and we get our output here. I'll just try and move this over a bit. Okay, I've got most of it in the window, I think, and so we get two pieces of information out here. We get one with just the sample statistics, so we get a mean and the number of observations in our sample. We get the standard deviation and the standard error of the mean. And if you remember from what we were talking about the other day, the standard error of the mean is the standard deviation divided by the square root of n. So if you were to divide the 8.767 by the square root of 75, you'd get 1.01. So down here is where we get the results from our hypothesis test. We can check that we've entered the right value by looking at the 156. That's the value that Roy Morgan was saying, and that's where we got that value from. So Roy Morgan was saying that on average people spend $156 a week on groceries. We've gone out and collected a sample just from Wagga, and we want to see whether our sample has a mean of 156 or not. We get a t-value, the degrees of freedom, the significance level, and it also tells you the mean difference between the test value and our sample mean. So if you do 169.50 minus 156, we'll get $13.50, and then we get the confidence interval for the difference. Okay, so let's start at the beginning. The t-value is like a z-value, and if we have a normal distribution, which we've already established for this data, then the likelihood of having something more than 3 standard deviations away from the mean is going to be highly unlikely. This t-value is telling us that our sample mean is 13.3 standard deviations above the hypothesized value. So that's a long way away from the test value. So because we know we've got a a normal distribution, we know that it's highly unlikely, based on our sample, that the shoppers in Wagga spend $156 weekly on their groceries. Now, the degrees of freedom is just n minus 1, and it's based on the sample size, and we just need to think of this as a measurement that we need to look up the critical value for the t-value. So if we were looking up a table for the critical value, and I'll explain this in a minute with a separate video, we would have to look up 74 degrees of freedom, not n, which is 75, to get the appropriate value from the table. Based on the fact that we're 13 standard deviations away from the mean, the p-value is less than 0.001. Whenever you see 0.000, this means it's really small, but it doesn't mean that it's exactly 0. So you should always report this as less than 0.001. I've talked about the mean difference. This confidence interval here is centered around the difference, so it's giving you the confidence interval of the difference. If this confidence interval contains zeros, so if it goes from a negative number to a positive number, then there's not a significant difference between the hypothesized value and the mean of your sample. In this case, both of these are positive, and so there is a significant difference. So when you do a one sample t-test, the two things that you really need are the t-value and the significance value, or the p-value. These two things are what I would report in a paper or something like that. But make sure, as we have done, that you check that the data has a normal distribution or approximately normal distribution before you start. Otherwise, the results that we get here are meaningless and you cannot rely on them.